My name is Dat No. I'm a solutions architect here at Arise. I work very closely with a lot of our kind of customers, kind of at the ground floor, really kind of digging into the details and figuring out, hey, what are the issues that they're trying to solve, and working with them through those issues. But really excited today to present with Jason here, what we kind of, our understanding of how are people doing summarizations? What does that look like? What are the challenges? Yeah, so go ahead, Jason.
Yeah, and I'm just co-founder here. Excited to be talking about evals. It's something that is on our mind. We're working through a lot of real evals and production scenarios with our customers, and just trying to bring back some of the insights that we see in kind of being on the ground with this stuff. Um, and that will have you take it away.
Awesome. Amazing. So yeah, today we're going to go over, summarization. I think it's a use case that a lot of us have kind of heard, but maybe haven't dug into much detail and like, okay, if I'm going to do this, what does it look like? And so really the first thing I really want to talk about is, why have we seen this really come up in our space kind of a lot? So when we think about, the age we live in, the new technologies that are available, here, the rate of information or just the growth of the data that we see in the past, not only 5 years, but, just in general, even with generated data and generated models, summarization actually has become extremely important. And some of the factors why is because not only is there a growth or kind of this massive influx of just data, a lot of that data is actually unstructured, right? It can come in many forms, whether it's unstructured, maybe, long form textual documents like, you can think instructions or, requests for proposals, things like that. Just think about the structure of the data is unstructured. And with the advent of, things like LLMs, even more is being kind of generated. And so with this massive amount of unstructured data, right, it's actually really important to be able to parse through it and get, kind of filter out the most important things. And so some of the benefits of summarization include things like, you as a human, when you understand you can't read, 5 books at a time, whereas maybe, a transformer can look at many words at kind of one time and parallelize. So for you as a human, it's important that you reduce the amount of time because just of the sheer amount of data that exists. We can search or find things much faster in summarizations or shorter texts than we can in extremely long texts. Maybe the concepts, maybe, the important kind of relevant information. And lastly, it makes it really, really easy to understand and learn as a human. I think a lot of us maybe nowadays go to, chat GPT or whatever large language model, and maybe there's something we don't understand and we kind of ask it, hey, can you explain this in a way that's easily understandable? And so that's why summarization has really kind of exploded in terms of what we see with our customers. Jason, anything you want to add here?
One thing I would add is there's like a handful. There's a lot of things that GPT-4 is great at, but like in these large language models, awesome at summarization. It's just game changer in terms of summarization. So we're seeing lots of customers try to take advantage of that, and and I think that's kind of like the driving the proliferation of the problems that then arise once once you're doing summarization or trying to do it.
Awesome.
Cool.
And so I think one thing too, maybe an example of the use cases that we're starting to see out in the space, and you can kind of these are just kind of examples that I pulled from the internet, but really, if there's like a lot of information across whatever kind of docs, PDFs, even you can think just any system that has a lot of unstructured data, and you really want to put that into like a place that's more kind of grokkable or digestible. We can really take a look at kind of that. Okay, looks like we have kind of a question. Oh, we have hands up. Okay, Sarah. Also, if we have folks that are asking questions, let us know in the chat. But so if you're have a system that has a lot of unstructured docs and you want to summarize across, that may be kind of a use case. Things that we're seeing that are kind of useful are things like if we're here, we're avid user of Gong. Instead of having to kind of scroll through or figure out, hey, what was talked about in this meeting, it's really nice to be able to just look at a summary of like, hey, these are the points that were talked about. Here are the next steps or deliverables. And it's just a much faster way. I feel so much more efficient whenever we're kind of doing that, instead of having to kind of listen through the call and find the pieces that I think are important. Having that kind of already done for me is super valuable. Another kind of use case is maybe an example like Amazon, added, AI, review summaries, meaning instead of me having to parse through every single review for a specific item, it might just be nice to get like a high level version of all of those reviews or summary. And so these are examples of kind of use cases, and we'll walk through, hey, as people are building these use cases, what are they finding out? What are they understanding? Things like that. Yeah, Jason, anything else you want to add here?
I think it's good. I mean, I think we're seeing all of these across customers and different. I've seen a wide breadth of different customers doing every single one of these.
Awesome. And so the next thing I want to talk about is if you ever read any kind of research papers on summarization or like maybe formal summarization, what does that mean? There's actually two approaches, or two ways that you can think about it. And so at its core, there's kind of, you can think two major ones, but you can combine them for a third. But the three primary approaches are extractive, abstractive, and hybrid. The extractive approach is straightforward. It essentially selects maybe key sentences directly from the source document to construct the summary. And so what this does is this ensures a high degree of like accuracy or factualness, meaning you're pulling directly from that. And the content is kind of lifted verbatim. And on the other hand, when we look at abstractive approaches, they maybe take a more interpretive route. And so this might be what you see in kind of large language models. So what this method does is you try to comprehend kind of the main ideas coming from the document, and then you craft a summary, much like a person processing information and then explaining it in kind of their own words. So you can kind of get a feel, and what you'll kind of see is most people go kind of with the abstractive unless they're like essentially only wanting to pull direct like lines of data. Maybe they're doing research and they want to find exactly what was said. So, it's extremely factual. But maybe abstractive is a way that we can get things that are kind of maybe more coherent. And the hybrid approach is really a strategic blend of the two, where you start with maybe extracting crucial content, and then rephrasing or adapting this content for maybe a more refined or abstractive kind of summary. And so each of these methods has its own strengths and in best case scenarios. For instance, while summarizing a typical maybe news article, for instance, the extractive method might suffice where you're pulling the actual facts from the news article. But maybe for content with like maybe lengthy dialogues, or it's a really strong or long, maybe complex document, where the ideas might be extremely spread out and a single sentence can't really summarize, the abstractive or hybrid approach might be more effective. And so, TLDR, extractive pulls out direct sentences. Abstractive really does what you think as a human does when doing a summary. And so what we see from large language models is mostly abstractive, unless otherwise instructed. And so just wanted to cover some foundational knowledge with summarization approaches. The next thing I want to cover is really long versus short docs. And I think this is really important to kind of cover. Long documents are called long documents because the sheer number of lexical tokens maybe in the source document is enormous, and it requires considerable amount of time for maybe the average human to consume the full text. You can think of these as extremely long, archive papers, maybe a long novel, maybe an extremely long transcript of a speech. And so these long documents often have more, you can think of internal data variance, meaning think about the book War and Peace, right? Extremely long novel, a lot of complex ideas. And the sheer amount of data you're going to cover in a long document, it makes sense. You're going to have more variance because the complexity of ideas and the flow and hierarchy of the ideas. And so these these kind of summaries on long documents tend to be more complex because the model, the human, has to understand the deeper relationship between specific keywords, topics, and phrases as the text grows. When we think about short documents, you can think of like maybe the review example for Amazon. These are independent. You can think text, meaning like in a long doc, these words, these texts, these chunks, they're kind of related to each other, but in kind of summarizing a bunch of news articles or reviews, they're independent kind of each other in kind of in general. And that's a different problem than maybe long. So whenever we talk about the summarization methods, we'll definitely talk about when you're doing these for long documents versus short, and we'll kind of cover strategies for both. Anything else you want to add here, Jason?
No, I think that's good. I mean, I think in one case you look at the long, you're like, okay, I'm going to overflow the context window and I got to deal with that type of stuff. But I feel like we've run in that same thing in the short side. So I have a customer where 1 million product reviews, and you're kind of run into potentially the same issues where just what you have doesn't nicely fit into a context window, which is probably a lot of what you think about as you're trying to think about like making some of these LLMs work. And then someone asked some questions around maybe evaluations. So how do you know the the quality and reliability of those on-call briefs and next steps? And we'll talk about evals at the end of this, of how do you use LLMs to evaluate the summarization in the end. We'll kind of get that. We're going to get to that a little bit at the end. And I think Christian asked about like evaluating LLMs in conversational AI context. I think we have a couple different series in the eval set here. This one's a little bit more summarization, and if your conversation is designed for summarization, that this probably fits. If it's generally trying to understand if the conversation, eval for the conversation, we've seen a lot of different approaches. So I have a customer today who's checks whether the conversation's answered by a citing doc for support. And I think all this stuff is each eval tends to be based upon the use case, and this specific use case we're focused on is summarization here.
Yep. And then to Emmanuel's question is, how's the quality and reliability
Yeah.
of those gong call briefs? Well, compared to what I was doing before, which is having to just like read through the transcript or maybe like go to where I was talking about a certain thing or the customer was talking about a certain thing, I think it's light years better than what my old workflow was. But it would be interesting to actually measure things, and I'm sure Gong is measuring quality and reliability as they build. But great question. But compared to my old workflow, Emmanuel, much better, much more useful. So what are some of the challenges when it comes to summarization? This is going to be really fun and kind of the meaty part. So here's where the complexity and the fun kind of begins. So specifically for long documents, but this happens also with short docs. If you have you can think 10,000 reviews. It's not like you can fit all 10,000 reviews in the context window, but as for long docs, as text tends to grow, the essence or the thing you're trying to capture becomes harder to find or to capture. And so making sure the way I think about a summary is like, is it a good representation of the larger population? Is the tokens that I have here or a sample of the tokens a good summary of the larger set of tokens? And so as the population gets larger, it actually becomes harder to capture kind of what's important, what's not important, the variance changes, and how do I also make this concise, right? So we're constrained based off of just summarizing large docs. And so really, when I think about long docs, what are some issues you might go through? So when we think about certain techniques like MapReduce or recursion steps, so MapReduce, what we can do is we can take a summary of this chunk and then a summary of chunk 2, and then make it much shorter. And then at the end of that, we can also take all these things and start recursively summarizing until we get to something that kind of makes a lot of sense. And so one thing that you might see with MapReduce, for instance, so here's a good diagram. Like, let's say you have this very long doc and you have a lot of chunks, but I'm just going to use 2 chunks to iterate kind of the point. Let's say this chunk size is 200. The other chunk size is also 200. And you always have some sort of overlap between your chunks so that there's like coherency between, so you don't lose data kind of between there. But the way kind of summaries work is, imagine you did a summary of like chunk one, and it was, everything in green here is a concept. Great. You kind of have that. So this second chunk right here, maybe the start of concept two is the majority of that particular chunk. But maybe we have some really critical detail from concept one in that chunk. We might actually lose that critical detail when we summarize, right? And so this can be something that you encounter with maybe something like recursion. There are benefits of recursion. Like, for instance, one of them is that you can parallelize a lot of this. So you're not having to sequentially run this through a call, and it doesn't take a lot of time. But the key points here is that kind of chunking based on like an arbitrary length throughout your entire long document may not be ideal. I kind of think of it as kind of like a good first step, but it's kind of dumb. You just think, hey, I'm going to chunk this up into 200 size token chunks, and then that should be good enough. Sometimes it won't be good enough, actually. And so we'll talk about later what are some better ways to go about this. And there's no way to know beforehand if like a really important piece of information is in another chunk, but that's dominated by another concept, like kind of in this case. So we'll talk about methods later to kind of go through that. And one thing I want you to understand is, just because there's more chunks of a certain concept or topic doesn't mean that it's a more important concept, or that it should dominate the summary. Meaning,
And
maybe a topic takes a long time to explain, and is somewhat important, but maybe another topic is extremely important to understand, but doesn't take a lot of, you can think, tokens to explain.
so,
So
one note I would add on this stat is you kind of drop map reduce, which has a lot of meanings and names. I think typically what you mean here is like, this is relative to like llama index or LangChain usage. They have like a map reduce chain, and that makes kind of summarization easier, which just it's not like the big map reduce system, but it works in a very similar way, which is break something up into a bunch of things that you're mapping out to and then reducing. So it uses the same paradigm, but really what we mean here is like, if you're using llama index or LangChain, there's these map reduce chains that will just automatically do this for you under the hood.
yeah, that's a good distinction. Appreciate that, Jason. And so, yeah, to that same note, another chain example would be something like refine, right? And so refine, as an example, what we do is like, we kind of sequentially go through the document and say, okay, for this first chunk, I'm going to summarize it. And then you actually combine it with kind of the next chunk, and then you summarize that. So you kind of, you are reducing kind of overall, and you're kind of making it through the document. And there's pros and cons to this one. The biggest con I see with refine is just the sequential nature of the process. If you've ever run a refine chain, it just takes a long time. And then, so that's kind of the biggest drawback, and especially making it through long documents, that might not be something that's that you want, is that it takes a really, really long time. But the idea here is, take a chunk, grab the summary, then take that summary, and then grab the next chunk, and then summarize. And then you kind of repeat till you're kind of all the way through the document. The pros here too is that you kind of get the flow of, like, generally the flow from here to here is maintained, and you might not lose maybe things like maybe an important piece of information that's kind of critical here. But there's also some, research does suggest that maybe this, because of the sequential nature of refine, things in the beginning might be overrepresented in the final summary, just because it's kind of carried through. So just one thing to note with refine. And we're going to talk a little bit about maybe better strategies for kind of long docs in this kind of aspect. And so the way you can think about it is, instead of just arbitrarily chunking a long doc by like 200, but by arbitrary chunks and sending them through, you can think of like a really good summary for long doc as like, imagine your kind of science textbook you had as a kid. And a really good summary for that massive textbook is actually the table of contents in the beginning, right? And so, of course, we don't have the table of contents for our docs, for our long docs sometimes. But if you think about it that way, that can help you understand this kind of next technique. But you don't want to arbitrarily rely on chunks based off of length and then chunk that way. You kind of want something a little smarter. And the proportion of text on a given topic doesn't really determine if it's super important. It may have some correlation, but it doesn't necessarily determine more tokens equals more important. And it's also use case specific. So long docs, again, this is going to be very different than short docs. And so I'm going to go into the first idea, and it's really how do we get that, you can think, table of contents beforehand? How do we do something a little smarter? And so what you can actually do is there's a great Towards Data Science post on this, which I can share in the chat. But essentially what you're trying to do is you're trying to find, you can essentially try to build out the table of contents of a particular document. So instead of kind of going in, you can think blindly, you can actually take some chunks of data, and depending on how granular you want those chunks to be, they can be every sentence or maybe larger. You can then try to form or split the document into chunks, try to get the titles and topics for each chunk. And there's a strategy here that I'll go through on the next slide of doing that. You can then get the embeddings and then start to group topics with chunks. And you might end up with something that looks kind of like this, where you're like, okay, I've then split up all my chunks and I kind of know the topics or the concepts that they're talking about. And then from here, you could think, okay, maybe I want to map reduce from these concepts. So I'm going to take all these chunks, map reduce upwards. And then at the end, you do kind of a final map reduce, or, taking all the summaries of all the concepts and doing one final summary with kind of all those concepts. And the benefits here, we're actually capturing the hierarchy, or you can think the semantic flow or concepts in that particular doc beforehand, which helps out your summary, right? It's like knowing the table of contents of your science book helps you really summarize that science book. And so there's a lot of flexibility that you can do here too, but the TLDR is, instead of kind of you can think dumb chunking a really long doc, you can actually do a little topic modeling and try to determine which chunks go with which topics, and then summarize from there on up.
And I think it's an interesting point, like how how much do dumb chunking is maybe just breaking it up evenly across the full suite versus like being smart about it. And I think it really depends also on your use case. Does it matter, or and then we'll give you some evals in the end where you can maybe compare results too.
Yeah, I think it's a really good point, Jason. It's like take the path of least resistance to value. So if you realize that your summarization is not very good, maybe you go a smarter approach. But if you also realize, oh, it's the dumb chunking works, great. And so the idea behind this is really take the State of the Union kind of transcript. This was done kind of that Towards Data Science post. And so what kind of happened here is, the TLDR here is you find chunks, you find semantically similar topics. You can actually take the embeddings for each chunk, and you can use something called the Louvain algorithm, which is really a method for detecting communities in large networks, right? And so the algorithm is kind of a type of hierarchical kind of method that seeks to optimize modularity. And so the basic idea is that you have kind of these partitions in the network, and modularity is a measure of like the quality of a partition in the network. And so we then put those into communities. I can link the paper after this, but the TLDR is you're trying to detect topics from the chunk and then kind of map them kind of together. And so what you'll get is, kind of the topics of your chunks that may look like this. And then over the long, the kind of doc, you may have different sized, chunks and different number of chunks for kind of each topic. But then you've kind of produced, you can think that table of contents for that really long doc. And so I'll link the Towards Data Science post. There's also a GitHub with code to kind of show you how this was done on this kind of State of the Union kind of transcript. But the idea is pretty straightforward. It's like, instead of dumb chunking, just try to semantically understand where things are in your long doc, and then it's much easier to summarize from there.
And I've continued to add that, like, a lot of ways you might have used to have done things, maybe the LLM just takes care of. So try the simple form first, see if it works, use metrics to compare, do something more complicated.
Yeah, I think the evals is a really good way to let if like, oh, is something more complicated needed. Yep. Okay, So let's move on to the other use case, where small docs, but maybe there's a lot of small docs. So you can think of like a Google set of reviews or Amazon reviews. Maybe there's thousands of reviews, or maybe social media posts or whatever product descriptions. Um, so while you can think of these as more independent events, meaning there's no hierarchy in the reviews, meaning there's just a lot of them and you can't fit all of them inside of the context window. And so how do we deal with this, and how do we get a good summarization with that? And so we've seen kind of on first iteration, a lot of people will just do like a random, I'm going to choose these random, for instance, reviews or product descriptions, and then try to maybe summarize off that. I think random is a really good start, but I think there's other ways that are maybe a little smarter. So depending on what you're trying to capture, right, should determine kind of the strategies kind of presented here. But maybe instead of, this is an example of a Glassdoor review, instead of just randomly choosing a bunch of Glassdoor reviews to summarize, hey, how is it, working for this particular company? Maybe you inject the reviews into your prompt that have a really high kind of usefulness, or you can think, X amount of people found this review helpful. You can think of kind of those strategies and like, I want to include these. You can also think about stratification. So for instance, if you want to make sure you cover the breadth of things people talk about and they left you could think positive, negative, or neutral Glassdoor review, you can start to think about stratifying, oh, I want a certain percentage of my tokens to be positive or negative or neutral. Maybe you want to catch variability between really long kind of reviews or maybe short reviews. The idea behind stratification is very similar to like sampling, but the idea here is you want to sample like whatever you're after, but you want to sample intelligently the reviews that you're kind of after, to capture, you can think, the breadth or whatever goal that you're trying to accomplish is. So wanted to cover other strategies there, talking about, how do we summarize more intelligently across a lot and numerous, you can think small docs or small text. Jason, anything you want to add here before I move on to the next piece?
No, I think that's I think that's good. I mean, I guess the one little thing I would add is that I think with summarization and watching customers use it in like reviews, that it was definitely not as simple as I thought it would be. Just, hey, put all the reviews in and run over all of them. It just, you get such a mix of reviews that like I'm seeing customers do something different, which is let me get them into groups first and then do something like, like some smart over it. So I think depending upon how you're structuring your summarization, the evals and how you evaluate them might also be different.
Awesome. And so now we're going to get into some of the building blocks behind evals and why evals are important and how they can help you determine, hey, are these more complex steps required or not? And so really, I want to talk a little bit about the 5 pillars of observability. And so maybe I can cover 2 of them, Jason. You can cover maybe the other 3. And so I think, evaluations are extremely important. There's a really good slide here I actually want to go through, why evaluations are really good indicators. Okay, when you think about yourself, right, from a cognitive perspective, when we think about just summaries, for you as a human, it's much harder to produce a very thoughtful, concise, and like factual, accurate summary than it is to do maybe a comparative analysis. So if I asked you to write a beautiful summary that's of like War and Peace, the book, that's going to take a lot much more work than if I say, hey, here's a summary of War and Peace, and knowing that you've read the book, is it a good summary or not? And so the same thing is true with large language models. Is, I think Jason said this a while back, but and I agree with him. I think it's much easier too for large language models to do a comparative eval. You can think, hey, is this good or bad, versus, hey, generate. So using the comparative, eval is a good way. It's much more accurate than kind of maybe the original thing it produced, which is kind of an interesting thing to think about. So when we think about evals, that's kind of how I kind of think about it. And so we'll walk through too, with specifically for evals, how we do this for summarization, kind of in code and through a collab. And then Jason, I don't know if you want to talk about the other ones too. I'll let you.
Yeah, that's I think the core thing is the evaluation set in here. So
Gotcha. Okay, great. And then, obviously prompt engineering is a piece of it too. And so what are evals? We can think of evals as like a way to, like I said, kind of give us a signal on, hey, was the generation kind of acceptable or not acceptable? And so whether you're doing these evals kind of on a single generation or you have a more complex chain, we kind of help you we give you the tools to kind of understand, hey, are these things, is the thing I produce kind of good or bad? I think the fundamentals of production evals, the first one is pretty straightforward. If you have your own, you can call them a golden data set or kind of a baseline or a set of tests that you know are kind of correct. Hey, here's the document and here's a really great summary. You can use things like that and measure, when we're thinking about good or bad, was this a good or bad summary? We can actually have measures that are similar to the classical ML world, like precision, recall, and F1, and actually measure, hey, if I switch out this prompt template or if I switch out the LLM engine, how does that perform on this kind of golden, data set or this kind of benchmark that I know is good? The next thing is that evals are task-based or specific to specific tasks. And so we'll kind of walk through, I'll show you kind of an example of our summary eval prompt and how we kind of define that. And so we can actually determine different performances based off of the specific use case. So if there's a specific use case and I care about this performance, I can actually match that. And the last thing is that evals can run across different environments. So whether you're in, Python and Notebook, or, you're using one of the chains, they tend to you want them to kind of run very quickly and don't take a long time to kind of run. And so here's an example of like the summarization eval and how it kind of works. So if this is your kind of, your prompt, kind of in your data, what we inject inside of the eval template is really, it's like, hey, you're a summary, you're comparing summary text, and the original document is trying to determine if the summary is good or bad, etc. So we inject actually, hey, here's the summary that was produced. Here's the injection of whatever you could think reviews or chunks of the long doc. And then we kind of have it grade based off of, compare the above to this. Your response must be, good or bad, should not contain anything outside of that. And this is how we can get metrics like precision, recall, F1, things like that, because we're using another LLM to grade that specific response or general summary. And so you can use the Phoenix library. So the Arise Phoenix library for evals. It's an open source library. I do recommend you check it out, especially if you're kind of building in the space. But outside of this, what we end up with is an eval, an LLM assisted eval specific to, in this case, the summarization task. And so we also do, like for summarization, for instance, we do offer like GigaWord, CNN-DM, and XSum for golden data sets. So if you want to know, hey, is my LLM any good? We actually have pre-tested golden data sets for you specifically for summarization, as well as some other tasks if you're also building outside of summarization. And so this is an example of the prompt template. And so we inject inside of here. You can also make this custom, meaning it's really easy and the ergonomics are really good to say, hey, actually, I want to not just do good or bad. I want to rate this as summary good, bad, or neutral, for instance. This was a so-so kind of summary. And so these can actually be changed on the fly. So that's the beautiful part about this framework, is that you can actually change and make this very specific to your use case. So you can take what's there and kind of build off of it. We also offer Rails too, meaning one important thing too is when you do an LLM assisted eval is like, if you want to grade things like precision, recall, you can think of like a confusion matrix. Sometimes LLMs produce, it might be good and might give a reason why it's good, but you didn't ask for the reason. And so having to do precision, recall, F1, build a confusion matrix off of, you can think some data that's harder to like categorize. The Rails here really help you it helps categorize explicitly into these kind of bins for performance metrics. This is an example of performance on our summary, think golden data set. And so using GPT-4 versus GPT-3, we can measure things like precision, recall, and F1 for the golden data set. We can also look at, for the good and bad, maybe, what's the accuracy or weighted average. And the really cool idea is like, this is real data, meaning, GPT-4 did really good in some areas where maybe GPT 3.5 turbo didn't do well in certain areas. But just an example of kind of a way you can evaluate at a high level. Hey, based off of all the things that I generated doing an LLM eval, this was kind of the evaluation of the entire data set. Of course, you could look at individual rows as well.
And people generate, I would say, like, this is kind of like, is it good? Is it good based upon these criteria? We've had people create evals that like also generate some other metrics like conciseness, but still recommend making it a categorical or binary variable that you're measuring against, the number of points that you care about, just because a numeric output becomes, becomes hard to break down into the problem areas like this here. So averaging a number misses a lot of information. So this approach we've seen a lot of people do, and just highly recommend versus creating like a score. I think the score approaches are hard to really compare where your problems are.
Yeah, and in my experience too, I think we've done with a few of our customers the classification with the evals, and it was really cool to see where the bads were and just look at the individual bad rows, because we did notice just from looking at them, there were like issues with maybe the prompt, or maybe there was issues with maybe the generation or even the injection part. So I think it tends to be a really strong signal too, whereas scores, it's like what determines the score, what's the rubric for the score. It's a little harder to maybe interpret. So we already covered this slide. Yeah, Jason, if you want to cover this one.
Yeah, so I think there's kind of comes down to how like when you're thinking of summaries and evaluating your summaries, it's the same problem in generating the summaries themselves. Does the summary fit into your context window? If it does, great, you're just chunking it up and coming up with a summary. Or does the summaries go over your entire context window? And typically our summary evals take in both the output that you have. So what you see is like what is the answer? What's the output? And then we also take in typically a very similar set of chunks that was used to create the summary. So we're looking at like the similar information that the original LLM used to generate the summary, and you're looking at the summary itself, and you're coming up with an evaluation of it. I do think that, I mean, what we've seen in experience is that LLMs are much better at judging their own output than they are at like generating something unique. So you look at this and you go, oh, okay, so he's the jury, judge, and generator. Is that a problem? I think in practice, it's not like you get you, you get pretty good results from these evaluating themselves. If you want to get fancy and maybe ignoring terms of service issues, if again, look at your terms of service, but using another LLM to evaluate your first LLM's output is always a great option as well. So don't get the same generator LLM, get a different eval LLM. But use the chunks, using the evals that we have, use the chunks that were used to generate the eval, looks at the summary, and then judges it. And so this is kind of the simple case versus, I would say the more complicated case.
Yeah. Yeah, I think one thing just to highlight, again, we are just covering like things that for maybe more complex use cases, you might need something a little smarter. But also, obviously, if you can just fit everything inside the context window and you produce a really good summary, and you don't encounter these problems, you may not need to use these. I think if you have any other questions, we'd like to definitely ask them while we run through some kind of code.
Yeah, let me do what I do want to show to example of is just what this looks like um in Phoenix. So Phoenix um Phoenix is available as a as a platform here as you're running your lane chain and llama index, or even now have a pure open AI wrapper as well. So if you're not using lane chain or llama index, but it gives you an ability to look at kind of what's going on under the hood. We kind of talked a little bit about, what's going on in these kind of map reduced chains from llama index, how they're kind of breaking down your documents, how they're bringing, a summary list of your documents up. So what you see here is really is a set of documents and basically a set of summaries going on that are, separate LLM calls being used and invoked to create kind of a summary that then gets kind of aggregated together into a bigger summary. So there's a whole suite of solutions to be able to visualize what you're stuffing into the context window, and then what's coming out of the context window from an output perspective, as part of the tool sets that we have. And Phoenix just runs in a notebook. So this gets kicked off by literally just a couple lines of code in a notebook itself. I recommend checking it out if you're trying to troubleshoot your summaries. Anything, let's go back to questions and see what other people have.
Yeah, I think Frank had a really good question, and it was,
Yeah.
couldn't you sort the spread by keywords? I think the answer to that one is you could definitely do that. I think with keywords, I think it's pretty, interesting approach. But I think it could be a little too specific, meaning like there could be different keywords that maybe describe the same concept. So I definitely would say, hey, definitely give it a try. But maybe topic modeling might be a more wider encompassing strategy than possibly keywords, Frank. But I would definitely try it. If the keywords get you there and it's straightforward and it's easy,
Yeah.
my whole thing is, why not? And then let's
And
see. Go ahead.
yeah, and I think what I was just showing there is there's Phoenix traces now too that allow you to keep track of the eval calls that are occurring. I definitely recommend to like coming up with some criteria, evaluation metrics, so that all the different approaches you have something to judge it by. And then similar to, what we do for retrieval, there's been some discussions internally. Do we do like if you're doing a map reduce a summary, should we do kind of a eval at the map stage, at each individual stage in addition to overall, for better troubleshooting. But currently we kind of have a more, overall approach.
Yeah, I would say with the customers I work with in like
Mhm.
the productionizing, I think one of the strongest signals that we saw was really the evals. Like the first thing I want to do is for my customers is really generate the embeddings for, you can think the the prompt or response or the summaries, and then really color by what was the LLM eval. And so kind of without fail, we've always found kind of something that was happening when the LLM determined, hey, this is not a very good summary. And we've kind of really started from there and then look through kind of the rest.
Yeah. Let me share one more screenshot just so someone can see. So there's a couple chains run here for doing different types of summaries. And just worth noting, the stuff document chain is typically like stuff everything, it's literally one LLM call, stuffing your entire summary in it. And note it's pretty fast and short. Um, but these refine and map reduce kind of go up in quite a lot of time. So it depends on how big your docs are, what you're trying to do, how you're doing them. Just note as you get to these more, call it fancy techniques, and it's just not, it's multiple LLM calls, or in some of these cases, I'm not even, it's a lot of LLM calls. And, I don't even know how many of these are necessarily even in parallel. It's quite a lot of calls. The each, it's just time consuming. Do you have the time to do this? Whoops. So do check out Phoenix. There's kind of the what I was showing there is there's tracing for Llama index lane chain if you want to trace your calls as you're trying to use these things to do summarization. And then what we've been showing off today is the evals and summarization here within Phoenix. So
Yep.
uh
And if you like what you saw today, also if you like using Phoenix, please give us some stars if you want on there. But definitely check it out. But
cool.
we're excited to go ahead, Jason.
Yeah, and I think Christos had one last question, which is it sounds like I've heard this a lot, like OpenAI is getting worse over the year, in terms of what it's doing. Um, I do think the the evals are a good way maybe to keep it honest, maybe use a different LLM, assuming terms of service are okay, to give you a metric on how well something's doing. I I've heard that from various people that it's getting that I've heard some folks that say that. I'm not sure if there's really evidence out there that it's gotten necessarily worse. It might be that all of us are just I've heard one side say that we're all just used to the answers, and that maybe we're getting used to seeing seeing how good it is, seeing how bad it is. There's another side who thinks there's RLHF going on and they're making it worse at a certain set of things. So I think the jury's out on that. I haven't seen evidence one way or another. But you can definitely use evals to track in some way, like come up with a good eval, maybe use even a different LLM to do that. Awesome.
Awesome. Thank you so much for joining us for this second part. We look forward to seeing you in part 3 and 4.
Thank you.